Hi everybody, it's David Hunter here from Hunter Geophysics in Melbourne, Australia, and I've been given some data from a user who owns one of the new Mala GroundExplorer radar systems, which employs what Mala call HDR technology, which essentially it just gives it's essentially like a stacking of the radar traces. And the end result is that you have a very good signal-to-noise ratio in the radargram data. And you'll see that shortly, but I'm going to show you how to process that data. So, and the other thing that I'm going to do is, because this is this particular user doesn't have any ability to record the GPS or total station data alongside the radar data. It's not actually logging the positioning data in real time. Instead, what he's done is he has collected the start and the end point X and Y coordinates for each radargram line, and we're going to manually import that data into GPR-SLICE. So I'll just give you a brief look at the coordinates that he sent me. As you can see here, there's the file name in one column, and then the start, northings, eastings, and elevations, and then the end of the line, northings, eastings, and elevations again, and of course the UTM zone number as well. Now, unfortunately, GPR-SLICE doesn't like it in that format. It prefers it in a slightly different format, which I've already gone to the effort of creating. We need file name, and then X0, X1, X start of line, X for the end of the line, Y for the start of the line, Y for the end of the line, and all comma separated. So I've gone and done that. It's a fairly simple thing to do in Excel. We can export that file to a CSV file if needs be, which obviously we need it here. So this is the actual radar data that's produced by the radar system, and we can see here there's RD3, RD7s, cores, marks, and RAD files, and an object mapper OBM file. That's used by Mala, by their processing software. We're not going to use that in our case. So I'm just going to fire up GPR-SLICE, and I'm going to go File, Create New Project, make sure that Mala GX is selected. And I'm going to call this project Mala GX Demo. Obviously you can call it whatever you need to. Press the New Survey button and close, and then we're going to go Transfer Data, and we're going to browse for the radar data. So just select that folder, press OK, and then search, wait for it to populate the list, which it's done, press the import button and wait for the complete option to go up there, and close. And we're going to go File, Create New Info, and this process is quite simple. As you can see, the file extension is already provided for us. All we have to do is go down right down here, radargram extension, press the import button, and it's already done. And make sure that we've got should say, make sure that this is an X survey. So click on that, and then press the import button, and this is what you'll get. And make sure that these are all zeros, by the way, as well. If you did this first and then realize that these are wrong, you can update these and then come back and press the import button again. It won't matter. It'll fix it. So as long as these are all 4 columns of zeros and then your file names, that's fine. And we're going to close there, and then File, Edit Info File. Got info.dat selected. We're going to go Mala Get TS to update the time windows and the samples per scan values. Now, it's not actually doing it here because I did it a moment ago when I first tested the data before I started recording this video. So it's not actually going to show you that it's doing it, but it has done it. It's just a case of the values were there from last time, so it doesn't actually update it anything. And then we're going to press the Browse X0, X1, Y0, Y1 button and press Yes. And we're just going to select the file that I've created in that format before, that I showed you before. Press OK, and it's going to update those columns. And you'll notice now that it's lost the file extensions here, so we need to manually put that back in. And I'll just click on there to get rid of that. And now we're going to use the RD7 files. And I'm just going to copy and paste these all in manually. And then press Save Edits. And that's pretty much done. From here on, If you've seen the other video that I created that shows how to do this with Leica data, it's pretty much identical, almost. Always, if you possibly can, go to 32-bit data. It's just higher quality. So we're going to go 32 to 32-bit. And as I mentioned before, we have a significantly greater signal-to-noise ratio. And this is in the raw radargrams before any gaining is applied. You can already see a nice clear reflection here, and this one as well, extending down to depth. So this is the benefit of the Mala HDR technology. So we'll go batch gain dash wobble. As is a standard operation for data processing in GPR-SLICE, we'll allow this to finish converting the data. And then we'll close out of here. And now if we go to the grid plot menu, we will see the layout of where all the radar lines were positioned. So that's okay. Once again, the green dots indicate the start of the lines, the red dots indicate the end of the lines. So this is obviously a zigzag survey. So we'll close here. And then we're going to go navigation, markers, and then artificial markers. And that's fine. And from here on, it's the same standard processing procedures as shown in the Introduction to GPR-SLICE training video. If you haven't seen that, that's on my website, www.gprslice.com.au, and then click the links through the GPR-SLICE help. Or I'll leave a link on the screen now as well. So this is all fairly straightforward from here on. So I shall leave you to it. Good luck, and if you need any help, I'm David Hunter, Hunter Geophysics in Melbourne, Australia. www.huntergeophysics.com or gprslice.com.au, and of course there is the GPR-SLICE Facebook group if you need further advice from the broader user community.